Today our topic is about ACE level physics topical lectures online for group classes over there. Let's start with the next topic that is related to kinematics. Okay, if I go to explain what is kinematics or what the branch of physics is named as kinematics, then it is related to main sections, that is mechanics, which is having its two parts like kinematics and dynamics over there. Mathematics and dynamics. That will be the next chapter in this course contents over there of ACE level physics. Here we are going towards kinematics, like mechanics is study of motion. Motion is named as mechanics, but here we can say we are going towards kinematics. Then we say kinematics is the branch of mechanics or branch of physics, we can say branch of mechanics in which we study about motion without discussing its cause. Discussing its cause over there means I am going to study about speed. I'm going to study about distance, displacement, acceleration, but I'm not studying about how much force is being consumed, what is the level of energy over there. That will be named as kinematics. And in the other branch that was dynamics, we will study that what is the cause behind it, how much force is consumed, how much energy is consumed, how that speed is maintained as a constant speed over there. We will study in dynamics in the next chapter. But right now we are studying without discussing its cause, okay? And first of all, I will have to move towards the first key term which will be used here. That is distance. Distance is, we can say, length of path between 2 points, two positions, is called distance. For example, here is your school and here is your home. And from home, you are following the road section over there and you are going to reach at your school over there. Then you look, this is the length of path. This is not the shortest distance over there. This is the length of path between these two positions. That is your home and that is your school. So length of path between two positions is called distance over there. It is measured in meters. It is a scalar quantity because it is not having any proper well-defined direction over there. And it is changing the direction at every moment over there. So we can say that is a scalar quantity. It is having magnitude and unit over there only. After that, I go towards the displacement to go for it. Number 2 is displacement. If I want to go from home to school and I use a helicopter there, then I will move straight to some direction, like I can saying 180, 185, or I'm saying here 180 exactly to the north from my home to the school over there. I say this is the direction properly where I will use my helicopter over there. So that will be the shortest distance with the proper direction from my home to school over there. The shortest distance between two positions is called displacement, and it is a vector quantity. It is measured in meters, and it is shown in red color here from home to school over there. So that is shortest distance. And if you want to calculate it in the form of position vector over there, then you can say it is D is equal to R2 minus R1, means you are taking some reference point for your school and then you are explaining it in vectorical form over there. Then you can take as displacement as a vector quantity from R2 to R1 as displacement should be taken into account. After that, before going towards speed and velocity, I will going to explain about what is rest and what is motion. If a body does not change its position with respect to some reference point, then it is said that body is at rest. And motion, if body is changing its position, if body does not change its position with respect to some reference point, or we can say with respect to its surrounding, with respect to its surroundings, then we can say that is at rest. If body is changing its position, with respect to surrounding, then we can say surrounding, then we can say that is in motion over there. And if both bodies are changing their position with respect to, then that will be relative motion, not to be our theory of relativity, how Einstein is going to explain that, will be later on discussed, inshallah. Okay. After that, rest or motion, now I am moving towards speed. So if for speed, I will have to change the position. So I will have to go for motion state over there. Then I will say rate of change of distance. Rate of change of distance is called speed over there. And that is, I can say speed is equal to distance over time. And I can say speed is a scalar quantity. And the rate of change of distance is called speed. Speed is measured in meter per second in SI base units. If it is given in kilometer per hour, and you want to convert it into meter per second, then you will, for example, it is given as 50 kilometer per hour. Like you are going to want to convert it into meter per second, then it means you are multiplying it by 1,000 and dividing it by 3,600 over there. Then you will get it, your answer in meter per second. Like you are getting 50 kilometer per hour for changing purposes over there into meter per second. Then you are going to getting your speed after multiplying by 1,000 divided by 3,600. You are getting your value in meter per second. Remember that whenever you are given with the kilometer per hour and you are being asked for meter per second, you will convert it by using this relation over there. After that, this is a scalar quantity and distance like that. We will have to move towards velocity there. Velocity is velocity, and it is not in any specified direction because it is changing distance with respect to time over there. Rate of change of displacement. Just remember that when you are using the word rate, don't use the word with respect to time. Like rate of change of displacement with respect to time, no. When you are using word rate, it is already hidden over there. You are talking with respect to time towards it. So when you are saying change in displacement with respect to time, then don't use the word rate of. And when you use word rate of, don't use the time with respect to time over there for this velocity definition. So velocity is equal to displacement over time. So its unit is meter per second, and it is also a vector. quantity, and it can be positive or negative. For example, you are saying here, this is a 5 meter per second in this direction, meter per second. And if you are talking in the backward direction, then it will be minus 5 meter per second. And this is shown for direction with the negative sign. This is not the negative sign like making its value negative, because magnitude of speed can never be negative over there. Only this is a notation. This is a negative to show the direction in opposite direction over there. So that will be the velocity introduction over there. Now I will have to move towards acceleration. Acceleration is basically, we can say, a rate of change of velocity. Is called acceleration. This is also a vector quantity. This is having units meter per second square. And it can be given in the form of formula. Acceleration is equal to change in velocity over time taken. And if I say here a simplified formula for it, I will say acceleration A is equal to final velocity minus initial velocity over time taken. And if I say this value is coming in the form of negative acceleration value and positive acceleration value. Positive acceleration value is like, I'm saying final velocity is larger, small, initial velocity is smaller, negative. I'm subtracting it, like I'm getting A is equal to 40 minus 10 over 5, like that. So I'm getting here 30 over 5. Then I'm getting answer 6 meter per second square. This is my positive acceleration. But if this will be positive when I am applying the accelerator. I am increasing the speed from 10 to 40 over there. I will get this acceleration with respect to 5 meter per second, 5 seconds over there. But if I say I'm applying the brakes over there, then acceleration, for example, from 40 to 0, then V minus U over T, when 40 will not be taken as initial velocity, it will be taken as 0 as final velocity, because I am applying brakes, minus 40 over 5. Then I'm getting minus 8 meter per second square over there. So that is negative acceleration. It can also be called as deceleration. It can also be called as a retardation over there. If I go for its graphical representation of displacement, there are basically 3 types of graphs. 3 types of graphs are available in kinematics motion over there. Then I will say here, first one is distance time graph. Then second one is, let's go for making 3 columns here. That will be easy to explain over there. Okay. I'm taking here distance time graph. I'm taking here speed time graph or velocity time graphs over there, and acceleration time graphs. Acceleration time graph, so I will use AT graph. AT graphs. Okay. When I say that how I should go for its representation, then I take minimum 5 cases for it. For example, I'm saying here the first case is when I'm taking distance time graph, I'm taking distance along y-axis, I'm taking time along x-axis, and I'm saying my body is at a rest, means distance is not increasing or decreasing its value. After that, for second case, I'm saying here, it is my distance on y-axis and time is on x-axis. Then I'm saying here, it is going to be shown in the form of a great inclined slope over there. Then I can say it is a constant velocity should be obtained. In that case, and it is showing a positive velocity increase over there. This is the second case over there. When I'm going towards the third one, I'm taking the distance along y-axis. I'm taking x-axis along time t over there. Then if I am going to take with this form that my distance is, displacement is decreasing its value to 0 over there, then I can say it is having the negative velocity because its gradient is going to give me the velocity over there, and y-intercept is going to tell me the initial displacement at that point over there. So it is giving a negative velocity over there, and negative constant velocity, I can also name it like that. If I'm going towards variable displacements going to be taken into account, then I'm saying it is going to be taken in this form. So in this case, when the displacement cover is like that, so speed is not uniform over there, then I'm saying it is having acceleration. And if I am going to take it more in this form, then I'm saying it is again a variable speed over there, and I'm having that acceleration over there. So these were the distance time graphs. These were distance time graphs, distance time graph over there. Always remember that these distance time graphs should be taken in the form of MCQs, where different conditions will be given, and you will have to identify which one is right for your answer over there. Now I'm going towards speed time graphs over there. I should also write down about its graph uses later on for different examples over there. Then I will say here that if I go for it, then I will say that the gradient of distance time graph will give me the speed over there or the velocity over there. After that, gradient of if I'm saying it is displacement time graph, then the velocity. If it is distance time graph, then it is speed over there. And it's y-intercept. Y-intercept means this one, like I'm highlighting this point, like this one, like this one, like this is y-intercept, where the point is touching over there. So y-intercept is giving me initial displacement. Initial, INITIAL, initial displacement is giving me these values over there. After that, I'm going towards speed time graphs over there. These speed time graphs should be exactly a little bit similar over there, but they are going to change this constant speed to constant acceleration, negative acceleration, and then for the curves, negative and non-uniform acceleration, and the non-uniform acceleration should be taken in all those cases. I'm just changing the color over here so that it can be a little bit differentiated. So I'm taking here speed, I'm taking here time over there. And one thing which I want to tell about this graph of distance time graph, I will say area under graph here will be meaningless. Area under graph in distance time graph over there is meaningless over there. After that, if now I move towards this velocity time graph over there, then I will say, for example, my car is moving at its maximum speed of the speedometer, then acceleration is equal to 0 in that case, because velocity is not changing. My car speedometer on motorway over there has approached like 200 kilometer per hour, and it is going constant speed over there. There is no speed breaker, or there is no any hindrance in its pathway over there. Then I'm going with the constant speed at the full speed over there. After that, when I was at rest and I'm increasing my speed with respect to time over there, then it is speed here, time is here, then acceleration is in positive direction, and it is a uniform over there. After that, this is my first case, this is my second case. I'm moving towards the third case. Third case is Again, to go with the negative slope over there, to show the negative acceleration in the form of retardation or deceleration over there, I'm saying it is uniform, but it is negative also. After that, this is number 3 over there. For number 4, I will simply say here, for number 4 here, when I'm talking about non-uniform accelerations over there, then it should be like this. It will be non-uniform acceleration. It should be like in this form. It should be non-uniform acceleration I am obtaining there. And this is non-uniform acceleration also. If I talk about it, what is its area and slope is giving to me? Slope is already, by using the word acceleration, then I will say gradient of this speed time graph or velocity time graph is giving acceleration, number 1, acceleration over there. And number 2, area under graph is giving us displacement traveled. Traveled over there. And if I talk more about area under graph, then the third one is y-intercept. Intercept will give us, y-intercept will give, y-intercept will give initial speed, initial velocity, which can be shown with the symbol over there, U over there, like that. I think so you are familiar with that letter also. If I go for acceleration time graph, I will say here, the same cases of the graph should be drawn as like that. I'm just writing about the results of it. I'm saying here that slope, like gradient of this graph is meaningless. Gradient of acceleration time graph is meaningless over there. And if I talk about y-intercept, then it will give me initial acceleration. Y-intercept gives the value of initial acceleration. Mostly in exam, such questions from acceleration time graph will not be discussed over there, but speed time graph and displacement time graph will be discussed in detail over there. And zero slope shows that body is going under constant acceleration. Zero slope or gradient will show that body is going under constant acceleration. Over there. And if I go for area under graph over there, the last point for this section, area under graph will give me, the area under graph will give change in velocity. Change in velocity. After that, now I am discussing the most important topic, which is related to kinematics, man numerical equations. Mostly teachers says that derivations are not required over there, but I prefer that they should be derived and students should know how they are coming as like equations of motion over there. And if I say here that speed time graph should be taken, then how we will go for it? I'm simply trying an uniform picture over there first. Let's go for it. I'm taking here y-axis. I'm taking here x-axis over there. I'm saying this is x-axis, this is y-axis. And along x-axis and y-axis, this is x dash. This is y, this is y dash. I'm taking here along y-axis, I'm taking speed or velocity. Along x-axis, I'm taking time over there. I'm saying that a body is in moving with a uniform acceleration. Let's suppose I take a little bit here, a statement for explanation over there first. A body is moving with initial velocity u, and it increases its velocity to v in time t over there. So moving with uniform acceleration. A body is moving with initial velocity u, and it increases its velocity to v in time t with uniform acceleration. Let's show this representation on the graph over there. Like your body is initially at this point. This is the initial velocity value u over there. And you are increasing its velocity with respect to time t over there up to value v there. So I'm saying here it is the point where this velocity is v after time t over there. Now, I say that this point and this point is having its vertices 0, comma u over there, and it is having v, comma t over there. Now I'm taking it in the form of down axis over there. I'm making a dotted line so that it can be understandable that it is not the main line or graphical representation. It is just like to show that how different scenarios can be built up. If I say to you, go for with these vertices, like this is your x1, y1, this is your x2, y2. I say to you, go and calculate its gradient over there. You know the formula, m is equal to y2 minus y1 over x2 minus x1 over there. Then you can say here that this is x1, this is y1, this is x2, this is y2. Okay, now I'm taking here, I know that the gradient of speed time graph give me acceleration. So I'm going for acceleration is equal to y2 minus y1 is v minus u. So it should be t comma v. Wait a second, a silly mistake has been done over there. It is t comma v. It is t comma v over there. So y2 minus y1 v minus u over 0 minus t minus 0 over there. T minus 0 over there, and you are getting v minus u over t. And from here, you can make your first equation of motion, that is at is equal to v minus u. So v is equal to u plus at. This is called your first equation of motion over there. If I go and take to you for second equation of motion over there, then taking the same figure again, I'm going for calculating its, say, this was my first equation of motion. Now I'm going towards second equation of motion over there. That I know that is having its formula S is equal to ut plus half at square, like that. So for that purpose, I'm saying here, I'm making the points clear. O, A, B, C, D. I'm taking the area in the form of a rectangle, in the form of right angle to triangle there. For that purpose, I'm saying here, for second equation of motion, we are taking area of figure OABCD of OABCD, that is equal to a rectangle like OD multiply DC, OD multiply DC plus 1 by 2 into AC multiply BC. AC multiply BC. So from here, if I say here like area under this whole graph is giving me distance, that a speed, I'm saying S or D can also be said over there. OD multiply DC. OD is T and DC is my U. So U multiply T. So it is length multiply width plus half into AC. AC is equal to OD. OD is equal to T into AC is done. Now BC. BC is, if I take this is whole V, this is whole V over there, and this is U over there, and I want to take only this to this distance, then I should go with V minus U over there. Okay, now it is UT plus half into T, and V minus U from the previous formula, we know that that is AT. So it is UT plus half AT square. So it is your second equation of motion. Let's go for third equation of motion over there. And third equation of motion, I will take this whole figure as a trapezium. I'm saying again here, I'm taking the area over there, and that area is S is equal to area of this trapezium, like OABCD. Then I say, as I know, the formula about the trapezium is 1 by 2 into height into sum of parallel sides over there. Then I say here 1 by 2 into height is, like if I say these two are the parallel sides over there, then height is OD. Then I say it is D into sum of parallel sides. This is V, this is U. V plus U over there. And that is S. According to first equation of motion, if I use that, I say V is equal to U plus AT is the main formula. If I make it in a proper form, V minus U over A by making T as subject, and I should replace this T from here, then I will say here that it is going to take S is equal to 1 by 2 into V minus U over A into this original T over there. So I was replacing this with 2V minus U over A. T should not be there. T is already done over here. Now I should take V plus U over there. V plus U over there. Now look, 2A is coming towards S. 2AS is equal to, very simple. In O level and IGCSE, you have studied about the basic identity of geometry, algebra, that V minus U and V plus U, A minus B, A plus B is A square minus B square. That is B square minus U square. So this is your third equation of motion. If I take all of these three equations with respect to my gravitational acceleration, like the ball is falling freely downwards toward Earth with free fall acceleration of 9.81 meter per second square. If it is falling downward, then I am just replace my acceleration with G, like V is equal to U plus GT. S is equal to UT plus half GT square, and 2GS is equal to V square minus U square. But if body is moving in upward direction against the gravity, then I will say here that V is equal to U minus GT. S is equal to ut minus half gt square. 2gs is equal to u square minus v square there. Okay. So this is our little bit kinematics. And this was the complete overview of this whole class in which we study about speed, displacement, acceleration, derivations of formula over there. In the next class, I will move towards projectile motion. And I will also go for doing some past paper questions for you related to kinematics topic over there. It's up to you to do your practice on your own. Revise this lecture again and again, and you will be clarified with the easy concepts in the best way. Thank you so much for today. Allah Hafiz.